We're starting Unit 5 at Trigonometric Ratios, and the first section that we're going to do is 5.1, Trigonometric Ratios of Acute Angles. First, we have to review some material from grade 10. Everything you did a lot of what you did last year was with a right angle triangle. So a right angle triangle has a little box in the corner here that tells you it's a right angle. And then whatever angle you're talking about, we maybe have an X there or something. The side opposite it is called opposite. The hypotenuse is opposite the box, the 90-degree box, and then the other side is called the adjacent. So last year you learned SOH CAH TOA. SOH CAH TOA is telling you that the three primary trigonometric ratios, the sine of an angle. So the sine of angle A means you're going to find the length of the opposite and divide it by the length of the hypotenuse. That's what the sine of an angle is. The cosine of any angle means you're going to find the length of its adjacent side divided by its hypotenuse. And then the tangent of any angle, which is like your slope, is the opposite divided by the adjacent. So those were your big three from last year. Now something new we have this year is the reciprocal function, f of x equals 1 over x, and we're going to match that up with trig now. The primary trig ratios that you learned last year, SOH CAH TOA, also have reciprocals. We're going to use this Greek letter theta, spelled like this, to represent angles. So you might have used that last year, or you might have just used an X or a letter, but we're going to use theta a lot. There's other Greek letters that are really common for use in trigonometry, and you can take a look at them on page 279. So here we have our primary. These were last year. Primary. Sine, cosine, tan, we call those primary. Okay. Now if we flip sine over and make it 1 over sine, that gives us cosecant, and that's the reciprocal of sine. So cosecant is the reciprocal of sine. If we take cos and flip it over, we get secant, and we flip tan over and we get cotangent. So you're going to have to memorize these three words. And not once we flip sine over, so remember sine was originally hypotenuse opposite over hypotenuse. That means its reciprocal is going to be hypotenuse over opposite. Something that is important to remember is just some notation. If you see the -1 up there, that's not the same as the -1 outside. We're not going to use this. Right? You don't have to worry about this. Sine with a -1 up there is read as the inverse of sine, sometimes arc sine, but that's more rare. It's not the same as the negative out here, which is if we were flipping over the whole thing. So the most common one you're going to see is you're going to see it looking like this. Usually instead of writing sine to the -1, we're just going to write it like this. Okay, so it's usually fairly clear which one you're supposed to use. Example 1. Draw an isosceles right triangle with a non-hypotenuse side measuring 1 unit. So take a second, pause the video, do that now. Draw yourself a right angle triangle and put a box in one corner. Okay, and you're going to label one side with the box and one side with theta. So theta kind of looks like an oval with a bit of a line through the middle, a little bit curved usually. And we're going to label the sides 1 unit each because it's an isosceles. Question says we have to determine the value of the hypotenuse side. So if you haven't drawn that yet, press pause and draw that. Okay, to calculate the hypotenuse, remember the formula to calculate the hypotenuse is a squared plus b squared equals c squared, and it's important you get the letters representing the right parts. A and B are the two legs. C has to be the hypotenuse. You can't mess that one up. The other two you can mix up a little bit, and you know the hypotenuse because the hypotenuse is the line that goes straight through the right angle. Whatever line it crosses is automatically the hypotenuse. So C is the hypotenuse. And A and B are the other two sides. They're here and here. So if this one is A, well, my pen tool's not that great, then this one here would be B, but they're both the same, so they could both be, either could be either. So to calculate the hypotenuse, we've got 1 squared plus 1 squared. plus, oh, I don't know what happened there. 1 squared plus 1 squared is going to equal c squared. That gives us 1 plus 1, right, which is 2. So 2 is equal to c squared. Then the square root of 2. Square root of 2 is c, and that will be a positive square root because it's a length, and lengths are always positive square roots. So we've got the value of c. C is equal to the square root of 2. We're going to leave it in radical form because that's exact. We don't need to try to get some decimals in there. Now we want to fill in this chart. Sine is opposite over hypotenuse. So let me just switch colors here. Sine, since we're talking, here's the theta, right? Here's my theta over here. So I'm looking at the opposite. So the opposite is whatever, when I draw a line through my theta, whatever, oh, it hit the block there, whatever side it crosses is the opposite. So in this case, A is going to be my opposite, which is 1. The hypotenuse, we figured that out, is a root 2. So sine of theta, remember this is theta here, sine of theta is 1 over root 2. Cos of theta, cos is the adjacent. So in this case, our adjacent is here. So our adjacent is 1. Our hypotenuse we know is root 2. And then tan is opposite over adjacent. You have all this on your handout if you forgot SOH CAH TOA. So the opposite, we've already determined the opposite is 1. The adjacent is 1, so that this answer here is 1. Now we're going to talk about the reciprocals. These are our new ones. Cosecant, remember, is the reciprocal of sine. Cosecant is the same as 1 over sine theta. So I already know what it is, but I'm going to look at my triangle. If cosecant is 1 over sine, I can either just take my answer for sine and flip it over. So I had 1 over root 2. I can just write root 2 over 1. That's one way to get it, is to get it from my previous question. I already know sine, so cosecant is just reciprocal of that. Or I can go to the triangle, and instead of doing opposite over hypotenuse, I can do hypotenuse over opposite. So the hypotenuse on that triangle, that's the root 2, and the opposite side, that's the A, that's 1. So we get the same answer whichever way we do it. It's a little easier, of course, to just look at the answer already have. We already have cos. We know that cos is 1 over root 2. So secant is going to be the reciprocal of that, so that's root 2 over 1. I'm just going to write it as root 2 because I don't really need this 1 down here, right? I can take that off. Cotan is, so tan, SOH CAH TOA is opposite over adjacent, which means cotan is going to be adjacent over opposite. So my adjacent side was a 1, my opposite was a 1, that's a 1. Correct form. Angles are always measured or rounded to the nearest degree, like 4 degrees, not 3.7, and sides are measured to the nearest tenth, so 71.2 would be right, not 71. Or if the question tells you otherwise, of course, follow the instructions in the question, but if the question doesn't tell you how to round it, this is always how you're going to round. Example 2. If x over y is 3 over 7, then is y over x the same as 3 over 7? So think about that for a minute. So you have to flip them both. If you're going to flip x over y and turn it into, so if you're taking x over y and you're going to flip it to y over x, then you have to flip the other side as well. So the answer to that is no. They're not the same thing. We reciprocated, so we're going back to what we learned about reciprocals, right? We flipped this one over, and it looked like this once we flipped over, then we should have flipped this over too. So the answer should be 7 over 3, not 3 over 7. In other words, that's what IE means. In other words, if we already know secant is 1 over cos theta, we have that from the front of our page here. If secant is 1 over cos theta, then is this true? Is 1 over secant the same as cos theta? So we flipped this one, right? Secant is now 1 over secant. We flipped that one. Did we flip this side here? Did this side get flipped? Yes, it did. So that is true. Students make a lot of mistakes. They'll flip one side, but they'll forget to flip the other side. So that's why I'm pointing that out right there. It's a common mistake. So we need to remember that for this question. Determine the value of theta to the nearest degree. We've got secant theta equals 2.69. So look at your calculator. Unless something changed this year and someone just bought a new calculator, it probably does not have any of the reciprocal buttons on there, meaning secant, cosecant, cotangent. So they're probably not there. If you don't have your calculator, press pause for a second and go and grab it. You're going to need it now. So there's no reciprocal buttons on there. So we're going to have to remember that secant is related to cos, right? They're reciprocals of each other. Since we don't have a secant button on our calculator, but we do have a cos button, we're going to have to somehow change this into cos so that I can use my calculator. And on your textbook, page 277, there's some tech support there if you need help with what we're about to do here. So secant theta equals, let me rewrite that down here below because I'm kind of crowded. Okay, what I want to do, remember, I need my calculator here. I know I need my calculator because of the decimals. So I can't use secant on my calculator, I want to use cos. So what I'm going to do is flip over this side here. I'm going to change this to 1 over secant. I'm going to flip this side over because I know that that's the same as cos. So 1 over secant, if I flip this side, I have to flip the other side. It's got to be 1 over 2.69. And it's really quite common for students to only flip one side. That's why I showed you these examples over here. We have to flip both sides. If I'm going to put 1 over on this side, I have to do 1 over on this side to keep everything equal. So 1 over secant is equal to 1 over 2.69. Now 1 over secant, I know, is the same as cos, because we were going to memorize those from the earlier slide, remember? So 1 over secant is the same as cos. It's exactly the same. So I can just write cos theta there. It's exactly the same as 1 over secant theta. I don't need to flip or unflip anything. These two are exactly equal to each other. So I don't need to unflip this side here. This is still 1 over 2.69 because I didn't unflip or flip anything. All I did was exchange it for an equivalent expression. So now you can do this with what you learned in grade 10. I want to isolate theta. To isolate theta, we're not going to divide both sides by cos. What we're doing is cos inverse of both sides. So theta is isolated when I take cos inverse, and you have a button for this on your calculator, of 1 over 2.69. So take a second and put that into your calculator. Press pause on the video. You should get theta is 60 degrees. Okay, next page. Remember that angles of depression and elevation are always measured from a horizontal line. That's from grade 10, but I'm going to review that here. The angle of depression here, right, and the angle of elevation is here. The angle of elevation is you look at a horizontal line, here's horizontal, going up from there is the angle of elevation. So going up here, that's an angle of elevation. An angle of depression is going from a horizontal line down, so the bird is looking down from a horizontal line. Imagine their eyeballs first going straight horizontally, that's supposed to be horizontal, and then going up. That's an angle of elevation. Example 4. The angle of elevation from the bottom of a wheelchair ramp to a door at its top is 15 degrees. Okay, with word problems, we have to do one sentence at a time. So you're imagining a wheelchair ramp going up to a door. You picture one in your head so you have an idea of what you're supposed to be drawing here. Okay, the angle is going to be 15 degrees. The run, the bottom of the ramp, is 4 meters. You should be able to picture that too. Calculate the length of the ramp to the nearest hundredth of a meter. Draw a diagram. If the question says draw a diagram, you have to, and there will be marks for it. And if it's not done with a ruler, then it's not going to count. My pen tool that I have here does not work with the ruler. It just skips the whole time. So you should be using a ruler, but I can't here. So I'm going to try to draw a straight line. That's the bottom of my wheelchair ramp. And here's kind of a 15-degree angle going up like this. And there's a door up here, right? There's a door up there. And then we've got a line coming down, straight down like that, something like that. Erase a little bit of this. Oh, I erased too much. Start over. Okay. There's my ramp. There's my line down. We have a 90-degree angle here. And this is 15 degrees. It isn't, because it doesn't look like 15 degrees at all, but I have a hard time drawing that. This is 15 degrees. This is the ramp. And then the run on the bottom is 4 meters. 4 meters. We have to calculate the length of the ramp to the nearest hundredth of a meter. Okay. So what's important here is we have to figure out sine, cos, or tan if we're back in grade 10. The first thing you do is you identify the angle of importance here. This is our angle right here, 15 degrees. You draw a line through the right angle box. Whatever side it crosses is called the opposite, the hypotenuse side. Okay, this is the hypotenuse over here. You draw a line through your angle, the angle of importance of your question. Whatever that line passes through, whatever line it crosses is your opposite side. And then you're left with your adjacent side. So the sides in question for us are the ramp side, so this side's important. And we're given this side here, 4 meters, so this side's important. So from sine, cos, or tan, which one uses hypotenuse and adjacent? So that would be cos. Formula for cos is cos theta equals adjacent over hypotenuse. So we fill in our blanks. Theta is the angle. Got a 15 for that. Our adjacent is 4. Our hypotenuse, that's our unknown. Call that x. So cross multiply. This side is over an invisible 1. So if I cross multiply the x up, I get x times cos of 15 equals 4. I want to isolate x, so I'm going to divide both sides by cos of 15. You get your calculator and figure this out. Cos of 15. So this will leave us with just x on this side. And we'll have, if you've done all your calculations, you should get x equals about 4 point, what does it say, nearest hundredth? 4.14 meters. So we get an answer of x equals 4.14 meters. If you read the question here, it says there's often more than one way to solve trig problems. So this could have been done with everything you know from grade 10. It's just a grade 10 question, right? So I'm going to show you another way to solve the same question, and it uses our new material. Now the questions in the homework, if they don't tell you you have to use a secondary trig ratio, like if it says you have to use cosecant, secant, or cotan, then you can't do it this way. Forget about it this way. You're going to have to do it with this new method. But if it doesn't tell you, or if on a test or a quiz I don't tell you that you have to do it a certain way, you can pick the method that works best for you. So we're going to try here to do a second way here. The other way is when I look at the question, again, I'm still looking at the same adjacent, opposite, hypotenuse, and I'm thinking the same thing I was thinking over here, which is which ratio uses hypotenuse and adjacent, right? So hypotenuse and adjacent can't be cos, like we did. hypotenuse and adjacent can be cos. But now we know it can also be secant. So I'm going to do the same question again, but with secant, with our new one. So I'm going to put secant theta. Write out its formula first, is hypotenuse over adjacent. So we fill in the blanks here. We were doing secant of 15 degrees. The hypotenuse, right? The hypotenuse is our unknown. That's our x. Our adjacent is known, it's a 4. The advantage of this method is our unknown is in the numerator, which makes cross multiplication here easier. So when I cross multiply 4 up, I get 4 times secant 15, 4 times, but I don't have a secant button on my calculator, so this part makes it harder. I've got x isolated faster. So this was a faster way to isolate x, but now I'm stuck with secant 15, and I don't have a secant button on my calculator. But I know that secant is equivalent to 1 over cos, right? These are equivalent. This is not a case where I'm flipping one side and not the other. I'm not flipping secant. Secant is 1 over cos. So 1 over cos, and the 15 goes down there too, because secant is the same as 1 over cos. So now I can do this in my calculator. And when I do this in my calculator, I should get the same answer right here. X equals 4.14 meters. Therefore, the ramp's length is 4.14 meters. Anytime you have a word problem question, a question that's a word problem, you have to answer with a word problem too. With a sentence too. Last example, example 5. Rationalize the denominator. We did this already in 3.4. I'm going to give you a quick review question right now, but if you look it up in your notes, we did it in class. We did rationalizing. So rationalizing means to take something that's irrational and making it rational. The square root of 2 is an irrational number. In math, we cannot have any rational number in the denominator. It has to be rational. So we have to rationalize the denominator. So I'll just give you a quick recap of what that means here. To rationalize the denominator, I'm just going to multiply by 1 because multiplying by 1 doesn't change anything. So I'm going to take 1 over root 2 and I'm going to multiply it by 1. And my 1, if you remember, I hope you remember, my 1 is going to look like a root 2 over a root 2. So I multiply straight across the top. 1 times root 2 is just root 2. The denominator, root 2 times root 2 is root 4. So that's root 2 over, and we always take the positive squared here, root 2 over 2. That's rationalized now. That's all you need to do for that question, but it does come up in your homework because we have some radicals now because we're dealing with hypotenuse, and hypotenuse is often calculated as a radical as we had in our earlier example. That's the end of today's lesson. On your handout at the bottom are the homework questions that you need to do, and also a suggestion that you read some more points in your textbook, add extra notes onto these handout if you need to, do lots of practice questions, and ask if you need help.